So what we have here is we have a 150-foot rope that is hanging between two supports that are 100 feet apart. The rope is 6 pounds per foot, and we need to find the sag in the rope and also the minimum tension in the rope. And that's what we're going over in this video. If you want a video explaining how to solve for catenary loads, you can click on this video link. And if you find this video helpful, hit that like button and please subscribe. So the first thing we need to do is we need to probably just list the variables that we are given and then see which equations we need to use to find those unknowns that we're looking for. And so we have here the 150-foot rope, and so that will deal with S, but we got to remember that we have our coordinate system set up here where we have our x-axis and this is our y-axis. This is our distance C right here, and then our distance H is from there up to Y. Y goes up to that point. And so our S starts from the y-axis and goes to the support. So it's only going to be half of this. So we have that S equals 75 feet. And then we have our 100 feet between the supports. Once again, it's going to be half of that because it goes from the axis to the support. So we have X equals 50 feet. And then we have that W naught is 6 pounds per foot. So W naught equals 6 pounds per foot. Now we're looking for the minimum tension in the rope, and that is going to occur when the slope is the least, which happens right here in the middle, and that will be just the horizontal tension. So our T sub H, horizontal tension, is one of the variables we're looking for, and then our H, which is the sag, is going to be the other variable we're looking for. And so to find T sub H and H, we will need to use probably this equation and this equation. So in order to do that, both of these have C in them. And so in order to solve for C, given the variables that we know, we'll need to use this equation, which has S and X. So knowing that, we have that S equals C times by the hyperbolic sine of X divided by C. Now this is not an easy equation to solve because we can't just solve it for C. And an exact value for C would be an imaginary number, and so we kind of just have to get an approximation for that. And you can do that by, if you divide C on both sides, you have S divided by C equals the hyperbolic sine of X divided by C. Now the way you could solve this is through an iterative process where you just plug in values of C and get these two sides to match after having plugged in S and X, which we already know. So we can do that by making a table. We can say that 75 divided by C is on one side of the table, and on the other side we have the hyperbolic sine function of X, which is 50 divided by C. And then we just plug in values of C and put them right here. And so using your calculator, you can do that. So then we just pick a value for C. Let's start with 20. Say 75 divided by 20 is 3.75. The hyperbolic sine of 50 divided by 20 is 6.05. And then from there, we don't really know whether they go up and down. We just have to guess. We're going to go with 30. Do 75 divided by 30, and you get that is 2.5. And then the hyperbolic sine of 50 divided by 30 is actually 2.5528. And so we're pretty close there. I would go to about 4 or 5 decimals being the same in order to say that was C. But the more decimals that you get to match, the closer it is. And we're not going to go all the way with that in this video, but you just keep going, plugging in values for C until you got these to be the same. And so I get that C is about 30.8. So we have C there, and you just keep increasing, going just a little bit more with the values you plugged in for C. And you see here how this side is less on each side. This side is less than these values. Once that's switched, you know you've gone too far, and it's somewhere before the value that you just plugged in for C. And so now that we have C, we can use this equation, plug it in for C, and then we get our horizontal tension component, which is our minimum tension, T sub H equals C, which we found was 30.8 multiplied by W naught, which is 6, and you get that is 184.8 pounds of tension. So we've solved for that. We can write that right in here, that this is 184.8 pounds. And knowing that, that doesn't help us solve for anything unless we were to use this equation. Then we can find the tension and then to solve for H. But I'm going to use Y, and knowing that Y equals the square root of C squared plus S squared, so that's 30.8 squared plus 75 squared, and that equals 81.08, and then using this equation, H equals Y minus C, you get that 81.08 minus 30.8 equals 50.28 feet. So that is our sag in our cable, and we'll just write it off here, 50.28 feet. And that is all of the unknowns that we're looking for. So it's mostly just knowing how to use these equations and then plugging in those variables that you know and solving for those that you don't know. But it's not too complicated. So if you found this video helpful, hit that like button. If you have any questions or suggestions, you can leave them down in the comments. Also down in the description, I've got some links to Amazon and Teespring where you can go buy some student engineering merch. And if you do, that helps me out a lot. So if you're new to this channel, my name is Preston Palmer, Student Engineering, and my goal is to help other engineering students like me better understand engineering. So hit that like button and please subscribe.